This video is going to run through connecting a MultiPlus 2GX to a BYD intelligent battery. Now, some of the tools in this video can be used for other intelligent batteries, and the main feature is the new MultiPlus 2GX with its integrated GX card. This video is intended for technicians who have some experience with Victron equipment, and definitely those that are qualified in their electrical trade. I'm not going to run through all the nitty-gritty of designing a system and sizing wires and fuses and distribution and everything like that, but I am going to show you every functional connection required to get this system working with these major components. I'll run through briefly the components we've got in front of us. The MultiPlus 2GX, the BYD B-Box, these are 2.5 kilowatt hour units, the stackable, rackable units. This is a BMU. This part comes with the BYD battery box, usually. It can be purchased separately, and it's required to translate the comms cable between the BYDs and the MultiPlus 2GX. Now this is a brand new unit, so we'll start by opening up the bottom of the housing. You'll need a Phillips head screwdriver. This is a PH2. Remove these two screws at the base of the unit, and then with two hands, gently remove this bottom section, and this will reveal the connections. Now the unit's open, I'll give you a brief run through of the bottom connections. Up the top left, we'll start with the GX card. This is the V CAN connection ports. These are the ones we're going to use to connect to our BYD battery. We also have a USB port, which you can connect a USB thumb drive to or USB accessories. There's a reset button, an Ethernet cable for hard wiring and internet connection to VRM, a V direct port. This is for connecting an MPPT or other V direct accessory. On this side, we have the V bus ports. These are if you need to connect the unit through to another MultiPlus for parallel or three-phase configuration. And there's other connections available here, which you can read about in the manual. We have the main battery positive and battery negative connection lugs here, and then the AC connections on this side of the unit. AC out 2, and AC in. We aren't going to be discussing the AC side of the system in this video. Lastly, inside here, you can see the ground lug connection point. And we'll actually start with these when we do our configuration. Now on the BYD batteries themselves, you can see here the state of charge light indicators. In fact, I'll turn the battery on for a moment and we'll see those light up. Next to the light indications, and if you see, it does a little startup sequence. This battery is working well. You can see the 4 green lights. They're saying the battery is virtually full. Beside that, there's an ERR point, and if this is red, the battery has failed, and you'll need to contact BYD. There's another light next to it which can shine up orange. This is a soft error, which is usually correctable. To the right of those, there's the RS485 ports. Now these connect to other batteries and also connect to the BMU. Then we have the addressing point, and then we have some other connections which we don't use in this feature. Lastly, the on-off button on the right-hand side. Then we have the terminal connections. The terminal flaps are accessible by opening up these little plastic doors. We have negative at the top, positive at the bottom, and also an earth pin at the bottom, earth connection. I'll now turn the battery off because we don't need it just yet. You can turn it off by holding the on-off button until the lights turn out, like so. I'm going to start by grounding the units. Next, we'll start making some of the other functional connections. The cables come supplied as a continuous length. In this case, for our active positive connection, we're going to add a fuse in line. So I've actually cut the cable, but I haven't removed any material. I've simply cut it and made a connection. We'll start with the negative though. Depending on your system, you may also have a DC bus to work from. In this case, because I'm just showing the connection between the battery and the MultiPlus 2GX, I'm not going to use a separate bus. Instead, what I'm going to do, because I have two batteries, is use back-to-back connections. So they're going to be connected like that. I have enlarged the gland at the bottom here. I can now insert the 2 battery negative cables, tighten it up to finger tight, and then take your torque wrench, calibrated to 14 Newton meters. Everything looks secure. We can now bring these cables around. It's important to keep these cables the same length. Because these batteries are now connected in parallel, if one battery cable is longer than the other battery cable, you'll get an uneven discharge and charge across the batteries because of the varying resistances. Open up my P negative. There's two connections at the top. It's important to tighten these screws with the socket and not the screwdriver. I'll slide you in. It's also a good idea, just pop that in to get it started, to use the farthest connections from each other. So the outer edge points. This minimizes the potential chance of an accidental short circuit. I'll pop that in there with the torque wrench. Now, the BYDs have a specified torque, but if you don't have a torque wrench, you can also tell just by the way the battery terminal moves where they're tight enough. So once you tighten it up and that battery terminal itself as a whole begins to move, that's tight. Now we'll move on to the positive connections. Here I've got a ceramic HRC, that's high rupture current ceramic fuse. These are important because of the high inrush currents and general high loads that a MultiPlus will draw. So it's important to use a high quality fuse. To begin with, while I'm getting this all set up, I'm actually going to remove the fuse from the holder just so we don't get any accidental connections. I'm going to go back to back with my connections. We'll insert them through the gland. Give it a bit of a wiggle. Good. There's our nice secure fit. Pop that in there. Be careful not to get any metal strands outside the terminal connection. Second one, into the same spot. They're there. Now, we'll move on to the battery side. The batteries are off. There's no lights on there, but there is still some voltage on these terminals. So it will give you 12 volts. So be careful not to make any unintended connections. I'll also take the second one. Back to the M10. Again, I'm looking for that movement on the battery terminal to know that I'm tight enough. Now I've got positive and negative connected. I've got my positive cables here with some voltage on them, but not full voltage. The batteries are switched off. Take this guy here. Insert it nicely. No spare bits of copper getting in the way. Same with this second one here. Alright, that's looking excellent. So they're all in there extremely securely now. That's all now the electrical power connections that have been made, and that's ready to move on to the next step. We're now going to move on to making the communications connections and supplying power to the BMU. Now these parts, some come supplied with the BYD equipment, and some you have to purchase from Victron that are specific to connecting to Victron equipment. The first cables that come supplied with BYD equipment is this pass-through RS485, which is a Cat5 RJ45 connection cable. This goes between the battery modules themselves. This allows the batteries to talk to one another. That's good. While I'm here, I'm also going to do the addressing on the batteries. Now the specific addressing of the batteries should be referred to in the BYD manual. Effectively though, each battery needs a number in sequential order, starting by 1 and moving to 2 to 3 to 4 to 5 to 6 and so on. This is done in a binary code on these dip switches. So I'll make the first battery here number 1 by sliding the first dip switch up, and I'll make the second battery here number 2 by sliding the second dip switch up. If you have more battery modules, you'll have to refer to the manual on how to program those with that addressing system and connect them with the RS485 cable. But for 2 modules, that's how this is done. The next comms cable we're going to need is to connect from the RS485 port on the BYD battery to the RS485 port on the BMU. Now the RS485 port on the BMU is the one that isn't labelled. So on the front of the BMU we have the CAN cable, and that's labelled here with CAN H and CAN L as the pins that are active. But over here, the unlabelled port is the one we connect our BYD batteries to, the RS485 connection there. This cable can just be a normal RJ45 Cat5 network cable. Victron sells these, and depending on the distance between your battery modules and your BMU, get one that's an appropriate length. So I take one end, click it into my battery. I'm actually going to click it into battery number 2, so the last battery in the string. And this guy is going to connect into the side there, that unlabelled port we mentioned before. And there's our comms connection from the batteries to the BMU. We also need to power up the BMU. It's on the back here. This may come connected if you buy a BYD battery box. It may already come pre-wired, but if you haven't, here's where we have to make the power connection. This is the cable, so it comes already crimped with its special keyed plug on this side. And on this side we have the positive and negative connectors, positive being brown but it's labelled, and negative being black. Now if you have a proper DC bus, you'd connect this to the DC bus. It may come pre-wired into your Victron, into your BYD battery box, but in our case I'm going to take some power off the batteries to power this unit. I can fit that terminal connection in like so, and I'll connect the positive. Can now take the other end and connect it to the back of the BMU. Now the BMU has its power connection. It's not powered up yet because the battery itself is still turned off. The next communications cable connection we need to make is the special CAN bus type A cable. This VE CAN to CAN bus BMS type A cable is specific to BYD and Victron. You'll need to buy this cable from Victron, although we do also supply the wiring guide, so if you want to make your own cable, if you need a longer length than what we have provided, or what we can supply, you can make your own. But it's highly recommended to use a manufactured cable for this point. This is an essential communications cable and the system won't work properly without it. You'll see on the cable, one end is labelled Victron VE CAN. That end goes into the MultiPlus 2GX VE CAN port. There's 2 VE CAN ports on the MultiPlus 2GX. It can go into either of them. The other one is the battery BMS CAN type A cable. This one goes into the CAN port on the front. We now have all of our communications cables connected up and we're ready for the next step. Now, looking over the system, everything seems to be connected correctly, but to make sure, I'm going to run a polarity test with my multimeter to check to make sure all the connections are right. If I have the polarity incorrectly connected, this is the point when I could do serious damage to the system, probably destroy it. So I want to make sure this bit's right. It's worth taking some time to do a test just before I power it up. So at this stage, I still have my fuses out, so there's going to be no connection through to the multi. I'm going to connect to the top side of the fuse, so the point that still has connection to the batteries. And I'm also going to connect to the negative side lug on the MultiPlus. I'll turn on the multimeter. You can see here now. I'm going to select DC. You can see there's 12 or 11.94 volts of DC. This is the standby supply of the batteries, although it'll give no current. When I switch the battery on, I expect to see this figure remain in the positive, and the fact that it's already positive now is a good sign, and to go up to 50 volts or more. So I'll turn the battery on. The battery's powering up, and we can see now we're at 53.28 volts. The polarity is correct. So checking positive, checking negative. Everything's looking good. I'll check the polarity of the other connection as well. That's also looking good. So we have correct polarity and a correct voltage. We're now looking pretty good to start the system up. So to get the system rolling, I'm going to need to take my two ceramic fuses here, slide them into the fuse holder, like so, and then simultaneously push them down into the fuse holder. This has now powered the system. It's providing charge to the capacitors. My BMU is now powered on. And when I use this switch at the bottom, I switch it up towards the front of the unit, the MultiPlus 2 will turn on. The unit's turning on. We can see the screens come on. I can hear it humming. And we're now ready to start commissioning. To start commissioning the system, we're going to connect to the Venus Wi-Fi network that the MultiPlus 2 GX is creating. The details about how to connect to the Wi-Fi network are available in the manual, but also on this sticker on the bottom side of the unit. You can see under the MAC address the extension A43 at the end, a suffix. If I click on my computer, I can see this Wi-Fi network that's being created. Here's our C43, not A43, C43. If I click that Wi-Fi network, it'll ask me for a password. The password is also written on this sticker as the Wi-Fi key. I'll enter the key. I'm now connected to the Wi-Fi network of the MultiPlus 2 GX. This can also be done on a mobile phone or a tablet using Victron Connect and the local Wi-Fi network. Once I've connected to the MultiPlus 2 GX with my computer, I'm going to open a new browser tab and open the address venus.local. This will open up the remote console for the Venus 2 GX, where I'm going to do the next stage of the configuration. Now we're connected to the remote console of the MultiPlus 2 GX. We need to make some configuration changes so that it can find the battery. By default, these VE CAN ports are set to VE CAN 256K. We need to go into the settings and then scrolling down, either using the arrow keys on the computer or selecting the down arrow with your phone. Let's go to the very bottom where it says services and then along to CAN bus profile and then select CAN bus BMS 500 kilobits per second and select that with the spacebar or by clicking this button here. While we're in the services menu, I'm also going to turn on the VRM two-way communication. This allows us to do things like further configuration of the MultiPlus 2 GX in VE Configure over the internet via VRM, which is incredibly handy. In this case, because we've got a CAN bus connected battery and we're going to use the DVCC feature, a lot of the programming is already done by the batteries themselves. They tell the MultiPlus 2 GX what charge parameters they want, and it listens. But I'm going to turn on the VRM two-way communication now. I'm now going to go up to the system setup and then down to DVCC and turn this on. I'm also going to go to the next setting, which is the shared voltage sense. I'm going to make sure this is switched off. This is actually a more stable system with this switched off, because most of the MultiPlus and the MPPTs have a good voltage sense on their own, and it tends to give a more reliable charge. I'm also going to go into the Wi-Fi menu. The MultiPlus 2GX has a built-in Wi-Fi. It actually has two built-in Wi-Fi antennas. One that we're connected to now to do the remote console, which is a local network created by the MultiPlus 2GX. The other one we can use to connect to my local network. By connecting to my local network and the internet connection over there, this will then be connected to VRM, and we'll begin to get some data from this on the internet. You can find out more about VRM in another video that I've made, available on Victron Professional, called Introduction to VRM. By going into Wi-Fi networks, you can see the internet connections there. I'm going to select Internet. Scroll down to Password. I'm going to enter my password. On a computer, you can just type the password with the keyboard. On a phone, you'll need to use the arrow keys up and down to select the right characters, and then across to move to the next one. Once I'm done, I can hit spacebar or click the button. It's now connecting to my local network, and I'm now connected to the network. Now that I've enabled the 500 kilobit per second CAN bus BMS, it's going to be time to restart everything and fire it back up again and make sure the batteries are being seen by the GX. I'm going to shut down the multi. I'll turn off the batteries. To turn them off, I hold the power button until the lights turn out. Alright, lights are off. I'm now going to turn everything back on again. Turn the power back on. Lights come on. You'll see now this battery will actually turn on this battery because they are all connected. If you've got a bunch of batteries connected together through the same bus, you only need to turn one battery on and its voltage will turn on all the other batteries as well. I can now turn the multi back on as well. It's powering back up. I'll need to reconnect to the MultiPlus 2GX Wi-Fi network on my computer. You can see I've been disconnected from the remote console. So I'll reconnect to that Venus Wi-Fi network. Just need to wait until the multi itself status turns on. Okay, it's now powered up. I'll reconnect to venus.local. Great. I'm now reconnected to the system. I can't see my batteries there yet. Hopefully they show up shortly. It can take a moment on first setting up a system for them to appear. They've now appeared. You can see the BYD battery box batteries at the top there. They're at 61% state of charge and showing 53.08 volts. Now, these batteries are probably not synchronized, so there may be some issues when I'm first charging and discharging them to get them calibrated. It's a good idea to have both batteries charged to 100% if you're going to be adding different batteries of different types, especially in bigger systems. So, I'm going to have a little look inside the batteries here. So I've clicked onto the batteries. I'm going to click across. The bit that's most interesting to me at the moment, I want to scroll down to the parameters at the bottom. Now at the moment, the batteries are still getting their calibration information from the BMU. So they're showing a charge current limit of 0. We hope that this is going to increase shortly to 70. We can see the discharge current limit is 70. Now that's 2 batteries, each giving 35 amps. If you had 3 batteries, you'd see 105 amps, hopefully. This information is also explained in the BYD battery manual. So I'll just give this a second and hopefully we see this charge current limit increase. If after several minutes, you can see it now increasing. Okay, and the system's going to stabilize at 70 amps of a charge current limit. If this doesn't increase, it's because there's some issue with the system. It could be the batteries are just too cold. It could also be the batteries are 100% full, in which case they don't want any more charge current, and they'll say the charge current limit is 0. Now these batteries are looking like they're behaving properly. I'm seeing 70 amps charge current limit, 70 amp discharge current, and a max charge voltage of 56.5. The system is now functional and working. We can now reattach the bottom tray to protect our connections. Of course, normally at this stage of the installation, you'd probably want to connect other accessories like MPPT or your AC distribution to the AC output, or your generator to the AC input. But for the sake of this video, we're now completed with the connection and commissioning of the BYD batteries.